Okay, for this last video, I want to focus on molecules that violate the octet rule by having more than 8 electrons around one of the atoms. And whereas for the things that violate the octet rule by having less than 8, you can predict that. Beryllium, you know, has 2, needs 4. Boron has 3, needs 6. Hydrogen, of course, has 1, needs 2. Take a look at this molecule, though. This is sulfur tetrafluoride. Sulfur usually follows the octet rule. In this case, it's not going to, and you can't see it coming. So what do you do in a situation like that? If you are someone who enjoys using nasal, you would probably start by trying to do nasal. And let's see what happens. I've got 5 atoms total, 4 fluorines and 1 sulfur. 5 times 8 is 40. 4 fluorines have 7 valence electrons each. 4 times 7 is 28, plus the sulfur has 6, 34. When I subtract the available number from what I would have thought would have been the need number, I get 6 electrons to share, and of course that would only give me 3 bonds. That's not going to work because if I start to draw the molecule by putting the guy I have one of in the middle and surrounding him with the other guys, I can see 3 bonds isn't going to cut it. I've got to have at least 4 bonds. So in this situation, throw nasal out the window, and it's really not that hard to do. You're just going to revert back to nothing but single bonds. Are there molecules where the central atom or some atom in the molecule is violating the octet rule by having more than 8 and yet has double bonds? Sure there are. They never ask you those. So when you've got a situation like this where nasal doesn't work, you can assume you've got an atom that's violating the octet rule and is going to have more than 8 electrons around it by the time you get finished. So let's draw this, and then we'll talk about when that can happen. You'd still want to work with your available electrons. We already figured that out up here. I have a total of 34 valence electrons to work with. So I'm going to give everybody a single bond. That used 2, 4, 6, 8 of my 34. I'm down to 26. Give the outlying atoms as many lone pairs as they need to get to 8. So each of these fluorines has 2 electrons nearby from the single bond with the sulfur. They each need 3 lone pairs. So that's 1, 2, 3 lone pairs, 4, 5, 6 lone pairs, 7, 8, 9 lone pairs, 10, 11, 12 lone pairs total. 12 pairs, that's 12 sets of 2 electrons each, is 24 electrons I just used. I've got 2 electrons left over. They go in a pair on the central atom. Okay, so it's pretty simple. Let's do one more just for practice. Let me get this out of the way. Let's try to do xenon difluoride. SEF2. Okay, if you tried to do nasal, you would have, it looks like 3 things following the octet rule. 3 times 8 is 24. 2 fluorines have 7 electrons each. That's 14, plus the xenon has 8. That's 22. Yeah, see? Nasal is only going to give you enough, 1 bond. And clearly, we're going to have 2 here. So put the guy you have 1 of in the middle, surround him with the others. We figured out that we have 22 electrons to work with. Give yourself single bonds. That's 2 4 electrons from my 2 single bonds. I'm down to 18. Now I've got to give my outlying atoms all of their lone pairs. 2, 4, 6, 8, 10. That's 12 electrons for those 3 lone pairs on each fluorine. And now I've got 6 left over. Of course, the leftover ones, as always, have got to go in pairs. I'm going to have 3 lone pairs around the central xenon. Okay, thanks.